Great, so did you give that a go? So let's have a look at the answer now. So again, as I did earlier, I've underlined the noun phrase, all the identified noun phrases, and I've put the head noun, what I believe to be the head noun, in bold. The first one, the supplied telephone number. So here we've got, well, it could be telephone number or number. I'm choosing to parse this with number as being the head noun. And what type of number? It's a telephone number, and more than that, it's the supplied telephone number. Those are the modifiers to my head noun. You may have chosen telephone number as a head noun, and that would be fine too. But nobody answered after 10 minutes, so I've got 10 minutes flagged up as a noun phrase. Minutes being the head noun, and the 10 being a quantity that modifies that number of minutes. I then decided to go to the station. So I've got the station as being a noun phrase with station as the head noun, and the station identifying the example of station. The next one, I've got the desk sergeant I eventually spoke to. So here I've got the head noun as being sergeant. Again, you might have had desk sergeant as being the head noun, but I've just put sergeant. And the things that modify that, describe that sergeant, are the fact that they're a desk sergeant, and that it was the desk sergeant that the reviewer eventually spoke to. So all of that forms the noun phrase. And then an officer, I've got as the next noun phrase. It's officer as the head noun, and you've got "and" to define, in this case, an indefinite noun. My mind, so mind being the head noun, and which mind is it? It's my mind. And then the last noun phrase I've identified was the coffee from their coffee machine. So coffee being the head noun, that's the thing that's being talked about. Which coffee was it? It was the coffee from their coffee machine. Those are the modifiers that then form that noun phrase. So, why have I got you to do that? Well, let's compare the noun phrases you've identified versus the aspects that you identified and see what we can see. So, noun phrases, we've got the supplied telephone number, 10 minutes, the station, the desk sergeant I eventually spoke to, an officer, my mind, and the coffee from their coffee machine. Now let's compare that to the aspects we identified, which were around the wait trying to get on the telephone, the wait when attending the station in person, the rudeness of the desk sergeant, the helpfulness of the officer, and the quality of the coffee from the coffee machine. And we can see actually that it's done a pretty good job by picking out noun phrases. There's quite a lot of similarity with the aspects. So by identifying noun phrases, it seems a pretty good approximator of the kind of aspects that we might want to pull out in a review. So one option is that we could take our review, whatever we want to split up, and to look for noun phrases, and then apply sentiment analysis to those sentences which contain identified noun phrases. So in looking for noun phrases, we've got built-in functionality in Spacey to do that. Spacey's a wonderful thing. So when we run the article equals NLP and then feed in our raw read from our file, as we did before, Spacey's doing all its magic there. So as well as the named entity stuff, it's also storing noun chunks when it's done all that parsing. And we can grab those by calling article.noun chunks. And that will then grab us the list of noun chunks within an article. And we can then, once we've done that, we can then just look for those noun chunks within sentences and then apply the sentiment analysis to those sentences. Now, there is a big caveat with this approach. It's that if we're then doing it in that way, the training data, and we're going to need lots of it to be fed in, we're going to need to have lots of training data that has the sentiment recorded at the sentence level. So there's going to need to be a manual exercise first to train this up to say this sentence is positive, this sentence is negative, this sentence is positive, etc. So we can build it up in the same way. So that but the review level stuff isn't going to work now. We're going to need to have the training data at that unit too. And just before we sort of close this off, I just want to give you a final word of caution having tried to apply some of this stuff in the real world, this is a very real issue that you will likely encounter. Any form of machine learning, as has probably been drummed into you by now, needs really good representation while it's training to be able to learn effectively. We need representation from all sides of the spectrum so that we get good examples of different types of things. So good examples of positive reviews, negative reviews, etc. The problem is that in a lot of applications, you may well find that, for example, if you're looking at patient survey data, people will have negative things to say, but you may well find the overwhelming majority of reviews may be positive, because generally, when people have come out the other side of hospital, they're very appreciative of the care and the hard work that's gone into their care. So you'll probably find that most of the reviews are positive. And that's a problem, because that means that if, say, 98% of your reviews, or even 95% of your reviews are positive, then it's only then what the machine's doing is it's learning which is the right output to come out with, how much of the time am I right by applying those rules. And effectively, if you've got a situation like that, all the machine will do is simply learn to say that everything is positive, because if 95% of reviews are positive, it's going to be right 95% of the time. Think back to the example that Mike gave, the extreme example right back in the first session, where he talked about building a facial recognition system that just facial recognition identification system that identified cop killers, and it was right 99.9% of the time, and it was really just generating a random number between 1 and 10,000. But that means it would be right 99.9% of the time, because it's thankfully, a very rare event. So you've got to be really careful with this, and to make sure that you're not just teaching a machine to say everything is positive, or you could have the opposite problem, that everything is negative. So be very mindful of that, particularly in natural language processing, particularly in sentiment analysis, to make sure that you're feeding in representative data. Okay, so I think that's probably enough for today, and hopefully I haven't bored you all silly with talk of grammar and nouns and indefinite articles and all that malarkey. I just want to close off by giving you some optional further reading if you're interested in this stuff. The first thing that I'd encourage you to read would be the TensorFlow text-based classification section on Mike's pythonhealthcare.org website. That will take you through an example of actually coding sentiment analysis in Python, and it does that by getting you to classify movie reviews based on a training set from the Internet Movie Database, IMDb. So well worth a read if you want to actually try out doing some sentiment analysis. It's also got instructions there for installing TensorFlow. If you have any issues with that, as I check out Google Colab, because Google Colab will allow you to write Python code that you can then run online. There's no installation issues, and it will give you access automatically to TensorFlow. It's already pre-installed, and to the kind of supercomputers that you really want to be using if you're doing this in earnest. So well worth checking out Google Colab. Just Google it. If you need any advice or help with that, just send me a message. And the other thing I'd advise you have a look at on Mike's Python Healthcare site is the section on topic modeling, which we haven't covered today, except very briefly just to mention it at the start. Topic modeling is where you're automatically trying to cluster similar documents together that are of similar subject areas. That can actually be really useful in some particular problems, and it's an example of something called unsupervised learning. So the kind of learning we've talked about so far are examples of supervised learning. We're giving it examples that it can learn from, and it knows whether it's right or wrong, so it can check itself. With unsupervised learning, these are usually useful areas where there are no examples. We don't know what the right and wrong is. This is unknown territory. And so the machine is just trying to look for inherent patterns in the data to try and cluster things together. So it's a really nice example of that. And topic modeling is actually also really easy to do as well. There's some really nice stuff built into the natural language toolkit. And Mike's section on topic modeling will show you some practical examples of things you can do to do topic modeling in the real world. But for now, that's all from me. I hope you've enjoyed today's session. If you do have any questions, any thoughts about natural language processing, any ideas, I'm always more than happy to talk to you about it. Otherwise, as I say, have fun, explore these extra learning resources, check out the wide world out there on natural language processing, and do have a look back over what we've covered today, just to make sure you understand everything. And I'll see you again soon. Goodbye.